video. Okay, so we're going to be doing day 3 of our quiz. Again, formula sheet, formulas I'm going to be going to. This is the sheet that I told you guys to print. So sum and differences, we're focusing strictly on the differences right now. We're only working on the differences, but all the ideas are exactly the same for our next section, which is the sum. The only thing that's different is the signs in between, but look at the formulas are all the same minus the way the signs are. So this idea that I'm going to teach you today is going to apply to our next topic as well, our next section. So let's go ahead and get going. Have some colors. So my first one says, review the steps of the proof of the identity. So remember that when we talk about these formulas, this can be your A value and this is your B. So when we plug it in, remember that the formula for this, I'll go ahead and write it out, is that if this is minus, then it's equal to, the formula says it's going to be equal to some sine of A cosine of B, and then it's going to be minus cosine of A sine of B. This is just the formula for difference of signs. So look, my sine, and it's this formula. That's all I did was just copy the formula. That's where that came from. So I'm not just making this up. You don't have to know that by heart. You're not supposed to have that memorized. You can, but it should be on your formula sheet. That is strictly a formula. And then all I'm going to do is plug in the values. So here's my A. I said that my A is going to be just that capital A. So A is capital A. My B is 3 pi over 2. So my A is the capital A. My B is the 3 pi over 2. Perfect. We're good with that. All right. Well, then from here to here, they simplified this piece. They simplified this piece. So I go, okay, well, what is cosine of 3 pi over 2? Because there's some type of error in here. So that's what we're looking for. I'm just working through this to see, well, can I find a mistake? So cosine of 3 pi over 2, my 3 pi over 2, remember cosine is the 0 value. Cosine is going to be the x value, 0. Cosine of 3 pi over 2 is 0. And I also want sine of 3 pi over 2. So sine of 3 pi over 2, I go to my unit circle. Sine is the y value. It's -1. So sine of 3 pi over 2 is -1. So I go over here and I go, okay, this matches, but wait a second. Look what they did here. This was a minus and then they switched it to a plus. Well, that's not right? There's nothing changed. Why would that change? Now, different than when I go from here, this is a minus and then I have a -1, then it should be a plus. But here, this is not correct at all. That's not right. So there's your mistake right there. So it didn't even have to do with the math part. So be careful because they kind of trick you on that. So it was just that they copied it down wrong, basically. And sometimes we do that ourselves. So it's just a learning lesson there. And that's all they want you to do. Just be able to recognize some of that stuff. All right, this next one though, this is where things are going to get tricky. So it says that we want to evaluate this where my x value is between 0 and 180. So we're only picking x values between 0 and 180. So what is x going to be so that I end up with this? All right, so here's how I go about this. I have what they gave me. Cosine of my 3x minus 180. And it's equal to -√3/2. And I want to solve for this. So here's what I'm going to do. I'm going to go ahead. I'm going to use my difference formula for cosine. And my difference formula for cosine, I'll write it up here for you guys. So it's going to be a minus. Again, all I'm going to do is I'm just going to be transferring the formula from my formula sheet. So it's cosine, it's a minus. So here's what I'm going to be using is this bottom one here, that plus sign in between. So it's going to be cosine of A minus B is equal to cosine of A, cosine of B, plus sine of A, sine of B. So this is the formula that I'm using. So this is my A, this is my B. And here's how this is going to look. Here's why I'm going to do this. I'm going to go ahead. It's going to be cosine then of 3x cosine of 180 plus sine of 3x sine of 180 is equal to my negative square root of 3 over 2. No big deal, right? You guys are with me so far? Well, I know what these two values are because they're on my unit circle. So if I go cosine of 180 degrees, if I look at the x value at 180 degrees, cosine of 180 is -1. I'm also going to look for my sine, which is 0. So I'm just pulling off my unit circle. So when I do that, I get that this value here is going to be -1. And sine of 180 is going to be 0. So again, those are for my unit circle. So this value right here is just going to be -1. This value right here is just going to be a 0. I could just substitute those in. So I kind of combine that all in one step. And what's awesome about that happening is 0 times my sine of 3x just disappears. That's gone, right? 0 times anything, 0. So I'm left with just a negative cosine of 3x is equal to negative square root of 3 all over 2. I don't like this being a negative, so I'm going to multiply both sides by a -1. So I get cosine of 3x is equal, this just becomes a positive square root of 3 over 2. Okay, so here's the tricky part. So you guys are great about this. This is great. We're just solving for x. But the problem with this is this one has, it's not just the value of x. This one has a value of 3x. This is where things get tricky. Okay, so how do I go about that? So I take this 3x, and I want to know, that's like looking at it, going around my circle 3 times. So I want to know, where is my cosine value going to be the square root of 3 over 2? And I want to look at going around my circle 3 times because that was a value of 3. So I'm going to go around it 3 times and find those values. I also have the restriction that x is going to be less than or equal to x is less, sorry, 0 is less than or equal to x is less than or equal to 180. So that's from this piece right here. So this is saying 3 times around, but I also have restrictions. So there's 2 things going on there. If this was a 5, then how many times around would you go up to? 5 times, right? Whatever that value is. Okay, so I'm looking for when is cosine x going to be square root of 3 over 2. X is going to be square root of 3 over 2 here at 30 degrees. It's degrees here, so I'm going to use the degrees value. So at 30 degrees, 3 pi over 2, I could look for that x value again. Oh, at 330 degrees. And I keep going around. So that means then if I go around, so that was 1 time around, on my second time around, it's not 30 degrees. Remember, I went around 360 already, plus another 30. So then the next one would be at 390 degrees. And then I would come back here, and this would be my second time here. So it'd be my 360 plus that 330. And so that would be at 690. And so I would add values of 360 again. I would add 360 to these. So I'm going to go ahead and just take a timeout for that for the moment and not do that 3rd time. There is another time around that I can do, but I'm going to go ahead and time out because this tells me my values for 3x. But again, we want to solve just for x. So in order to do this, at this point, I would want to divide this by 3 because 3x divided by 3 leaves me with just x. Then I would divide each of these by 3 as well. So I end up with x is equal, 30 divided by 3 is just going to be 10. This is going to be 330 divided by 3 is 110. 390 divided by 3 is going to be 130. 690 divided by 3 is 230. But look, remember, we only want in between up to 180 degrees. So this one doesn't work. We don't care about that one. So the only values that we cared about are going to be these ones right here, are those values right there. And that's going to match up with this right here. So again, this is saying 3 times around your circle. So 3 times around. So when you see this, it's talking about going around the circle, how many times around. So I treated this like it was an X one. I was looking for the values. I want to know where it was, but then I have to divide it. So if this was a 5X, then I would divide it all by 5 to get my actual degree values. So that one was tricky. That was something new. We hadn't seen that. I do have one more example that involves that. So hopefully the first time you see things, it's usually a little bit more difficult. And then it's easier. This one was in degrees, which is always easier for us to work with. The next one will be in radians. All right, so this one, it says, what is the value of cosine of 15 degrees? There is more than one way to get to the same answer. More than one way to get to the same answer. So be careful about that. Don't think that you did something wrong because your answer doesn't look exactly the same. You might have like a -6. Well, these are going to be the same, but you might have your -2. If you had something, one of the answers was negative square root of 2 plus the square root of 6 all over 4. Remember that those are equal. Just remember that they're the same. It doesn't matter the order that you solved it for. You'll also see sometimes, especially with the tangents, you'll get really ugly answers that are like different than what's up there. And put it in the calculator and they're going to be equivalent, or they'll probably guide you with the values to choose. So that totally just depends. But so cosine of 15. So I want to figure out 15 degrees. How can I get values that are on my unit circle to give me 15 degrees? I can do 45 minus 30, 60 minus 45. I could do any of those. I can't find my exact value of cosine of 15 degrees because that itself is not on the unit circle. But I could pick anything that I want. So I'm going to go ahead. I'm going to just do 45 minus 30 would give me my 15 degrees, right? Again, that's not the only one to choose. You could have done 150 minus 135. It's the same, whatever you want. So this is telling me then that cosine of 15 degrees is equivalent to cosine of 45 degrees minus 30, which we agree with. That is totally true. So I'm just going to treat this then like my A and my B value. I'm plugging it into the same formula I had up here. I'll kind of show that so you can see this one up here in the pink. That's the same formula I'm using. It's a minus, it's a cosine. This is the equation that I'm going to plug it into. And what this tells me is that I would have cosine of 45 degrees times cosine of 30 degrees plus sine of 45 degrees, sine of 30 degrees. And I would go to my unit circle. And all I need to do is look up these values on my unit circle. So these are values that are on the unit circle. Then it's going to be the square root of 2 over 2. Cosine of 30 degrees is the square root of 3 all over 2. Plus sine of 45 degrees is square root of 2 over 2. Sine of 30 degrees is 1/2. Square root of 2 times square root of 3, what's under the square root can be multiplied together. So that's just the square root of 6 all over 4. Plus, this is going to be square root of 2 over 4. Since they have a common denominator, I could write it as one term. So it's just the square root of 6 plus the square root of 2 all over 4. I cannot simplify this. The square root of 2, square root of 6, and my 4 cannot be simplified. I know 2 goes into all these numbers, but I can't simplify this 4 with something that's under the square root. If it was something like 2 square root of 6 all over 4, then I could simplify the coefficient, but I can't touch it if it's under the radical. So just as a little bit of a reminder, this is simplified. You cannot simplify these values that are under the square root with that 4. It doesn't work like that. So there's my answer right there. Am I going too fast? Are you guys okay? All righty, I'm gonna keep going then. All right, so this is gonna be one of those again where when I see this, this is telling me that I'm going around my circle 5 times. So when I would look for the values, I would be going around it 5 times, unless it has restrictions, which in this case it does. So maybe I don't need to do the full 5 because once my x value is greater than 2 pi, I'm done. So around, we'll do 5 times around. That's what it's telling you when you see that value. All right, so this is gonna be a sign. So I'll go ahead and put our equation. It's a difference and it's a sign. So sine of some a minus b is gonna equal sine of a cosine of b minus cosine of a sine of b. Right, so this is for my formula sheet. Again, we're going back to these same formulas. My a is going to be the 5x. My b is that pi. So I plug in the values. It's going to be sine of 5x cosine of pi minus cosine of 5x sine of pi. And I look to see, can I simplify any of this? Well, these values are on my unit circle, right? These are on my unit circle. If I go to my unit circle and I look at my pi, cosine of pi is -1. Sine of pi is going to be 0. So this value is just going to be a -1. This value is a 0. Awesome, because cosine of 5x times 0 is just going to cancel out. It's gone. And I'm left with just negative sine of 5x. And remember that this whole thing was equal to my square root of 2 over 2. So this is going to be equal to my square root of 2 over 2. And like we did before, I don't want this to be negative. If it has a negative there, get rid of it. The way you get rid of it, just multiply both sides by -1 or divide by a -1, however you want to look at it. So this would become sine of 5x is equal to negative square root of 2 over 2. Okay, so here's the tricky part. Remember then, we take this 5x is equal to, and I looked on my unit circle for sine to be negative square root of 2 over 2. And I could do this for up to 5 times around. And I notice here, it is in radians. So I'm looking for the radian value. All right, so how does this look? I go, my y values, I'm looking for negative square root of 2 over 2. So here's one at 5 pi over 4. And my second one for my one time around the circle is my 7 pi over 4. So I have that 5 pi over 4, and I have 7 pi over 4. And that's for one time around. So this right here was my one time around. And then I could go ahead and I could do my 2 times around. So my second time around then, if I'm going around one full time, I come to here, it's going to be 2 pi plus my 5 pi over 4, right? So I'm adding values of 2 pi. If I'm going to add values, if I have my 5 pi over 4 and I want to add 2 pi, then I need to have a common denominator. So 2 pi, remember, is the same thing as 8 pi over 4, right? This is just going to be my value of 2 pi. So 5 plus 8 is going to give me then 13 pi over 4. And then my next one would be 2 pi added to the 7 pi over 4, or 2 pi plus my 8 pi over 4. So it's going to be 15 pi over 4. So again, I added 2 pi to this 7 pi over 4 plus my 8 pi over 4 gave me my 15 pi over 4. So that's for the second time around. So I can do this for 5 times. But I'm going to kind of see where I'm at, because it's a lot of work to do all that. And especially if they gave me some restrictions, I may not need to do that, because my x value has to be between 0 and 2 pi. Now, just like we did on the front, once we had these values, once we had it, we divided everything by 3, because it was a 3x. Same idea is going to happen here, but instead of dividing by 3, we're going to divide by 5. We want to divide everything by 5. Now, if I divide by 5, remember it's the same thing as multiplying by 1/5, right? So if I divide this by 5, that looks ugly, doesn't it? It's the same thing as saying 5 pi over 4 times 1/5. So this is a value then of 5 pi all over 20, which is just going to be then pi over 4. So I'll write that over here. So I have x is equal to pi over 4. So this first one right here simplified to pi over 4, right? I do the same thing for my next one. 7 pi over 4 divided by my 5 or multiply it times my 1/5 is going to give me 7 pi over 20. Is that less than 2 pi? So I also have 7 pi over 20. I do it to my next one. So I'm going to do it to this one. 13 pi over 4. I'm going to keep going until I get larger than my 2 pi. So 13 pi over 4 times my 1/5 is going to be 13 pi all over 20. 13 pi all over 20. And then I could go ahead and I could do it again. And then I do want to point out, so this is a valid answer. This is which values are 2 of the possible solutions. So if I looked, my answers were just the first 2. They had those 2. This is valid too. This is correct. They only have which ones are possible. So if I wanted to find another one, I would do, if they ask for all of them, I would keep going. So I would take my 5 pi over 4 times my 1/5. 3 goes in this, so this would be 3 pi over 4. So this is 15, 3 pi over 4 is another possible answer. So there are multiple answers. They just asked for 2. So I could keep going, but I don't need to. So I just want to point that out. I can keep going, but pay attention to what it's asking. It didn't ask for all, it only asked for 2 of the possible solutions. I listed 4 here. There are more because this is only 3/4 of a pi and we could go up to 2 pi. So I would just keep going around my circle again and again until I got them all if it asked for that. All right, my last one for you guys. We've done, the ones today have focused on values on the unit circle. It gave you your hint of things being in between. The values here were given to you in radians or they were given to you in degrees. This is not given to you in either one of them. So this is when we have to use the triangles. So this is setting you up for the triangles. They'll tell you things about what quadrant you're in. All right, so this is a tangent. So let's go ahead. Let's write down our formula. They want, what are we, oh yeah. Here's what we want. I want tangent of A minus B. So tangent of some A minus B, the equation's going to be tangent of A minus tangent of B all over 1 plus tangent of A, tangent of B. All right, so here's the equation. What do I know? So I need to figure out, well, what is tangent of A? I know that my sine of A is equal to 5/13. And it says that it's between pi over 2 and pi. So pi over 2 and pi, that's telling me pi over 2 and pi, it's telling me that I'm in quadrant 2. So I know all students take calculus. I know I'm in quadrant 2. That's what this piece here tells me, is that I'm in Q2. I'm in Q2. So if I'm in Q2, then my sine is positive, which it is. Then that means my tangent and my cosine would be negative. So that's the only thing I know for my A, is the sine of A. So I want tangent of A. So when I look here, Here's my right triangle. I know my opposite and my hypotenuse. My opposite is 5. My hypotenuse is going to be 13. Then my adjacent side has to be 12. And I could do my 5 squared plus x squared is equal to 13 squared. And you could solve for that missing side and get that it's going to be 12. If that's the case, then tangent of A, tangent, remember our SOHCAHTOA? Tangent is opposite over adjacent, so opposite over my adjacent, which is 12. So there's my tangent of A value. So I now know this value and this value. But what did I need to make sure that I include with that? Yeah, the sign, remember? What quadrant are we in? We're in quadrant 2, which means tangent has to be negative. So don't forget that. That's going to be number 1 mistake because then your signs are going to be off. And if you look here, all these answers are relatively close, but the signs are switched. So be careful. Okay, same idea is going to happen with my tangent of B here. Oh, look, tangent of B. They gave it to me. They said tangent of B is negative square root of 13. I didn't even need to do a triangle for that one. So now I know my tangent of B values, and all I need to do is just plug this in, plug everything I know in. So it's going to be negative 5/12 minus a negative square root of 13 all over 1 plus negative 5/12 times a negative square root of 13. It's going to equal, this is going to be a negative and negative is going to make that a positive. Now here's something that I'm going to do. This is a fraction, it has a denominator 12. This one doesn't. So I want to go ahead and get everything that's above my line, everything that's in my numerator. I want to go ahead and get that so it has a common denominator. So I'm going to multiply this by 12 over 12. When I do that, then I have a common denominator of 12 here, and I get negative 5 plus 12 square root of 13, because I needed to multiply those two together, all over 12. Divided by, same idea here, this one, I'm going to get a common denominator multiplied by 12 over 12. So I end up with, this is the same thing, everyone, I'm multiplying these together, so it's going to be 12. A negative and a negative is going to make that a positive. So plus the square 5 square root of 13 all over 12. What happens when I have a fraction divided by a fraction and they have a common denominator? They just cancel out. Since these are both 12, I could go ahead and simplify that. And I end up with negative 5 plus 12 square root of 13 all over 12 plus 5 square root of 13. And I'm done. And that's going to be this answer right here. Done. We survived today. Tomorrow's, we're going to be very similar. We're just going to be working with the sum portion of it. So if you guys have questions for that, let me know. I'm sorry that I sent out the agenda late. I don't know what I was thinking. I have them all set up. I just haven't posted them. And so I think because I've done it, I've already posted. My apologies. If that ever happens and you're like, hey, you never sent it out, shoot me a text or a message on Remind, and I'll get it out over the weekend. Otherwise, you guys have a fabulous day. Thank you.
You have a good day.
Thank you. You too.